Alright, in this video here we're going to talk about solving equations graphically using method number 1, which is the x-intercept method. Right? So if you didn't see the last video that I did on this, where I just basically broke down the two different methods for solving an equation graphically and kind of step by step what you do with each method, you might want to check that video out. But this one we're going to go through the first method that was on that video, which again is the x-intercept method. So basically what we're going to do is we're going to first make sure that everything is moved onto one side of the equation and it's set equal to 0, which is what we have here, right? Our equation here is already set up that way, x squared minus 4x plus 2 equals 0. Now if this was equal to something else and there were some other terms over here, I would just have to add or subtract them to move them all to the same side of the equation so that I get it equal to 0 on that other side. Right? So what I'm going to do then is I'm going to graph this equation, x squared minus 4x plus 2. All right, so I'm going to use my TI-84 calculator to do that. So just kind of showing you what I did. So I went into the y equals button, which is, if you've never used one of these calculators before, right, the y equals button is where you type your equation. So you can see there I typed in x squared minus 4x plus 2, right? Use this button right here next to the alpha button. It says like x, t, theta, right? That's your variable button. So use that button to get the x's in there. So I graph that, and then I hit the graph button. Now, if you do this and your graph doesn't look like mine, it could be the way your window is set up. So what you can do is if you hit the zoom button, which is in the middle up top, it says zoom. And then if you choose number 6, it says Z standard. That takes you to the standard graphing window, which takes the x and y axis both between -10 and +10. So it gives you like a nice square window to look at. And that's usually where I start when I graph something, is that in that standard window. And then if my graph is like too big or too small, I can adjust the window from there to see, you know, what the graph looks like. Right, so here's my graph of x squared minus 4x plus 2. Right, so in this method, when we're trying to solve this equation, right, when I have all that equal to 0, really what I'm looking for then is the x-intercepts of that graph. So let me kind of sketch up here what this graph looks like. Just give it a real quick sketch. So there's my x and y axis, and this graph looks like it has two x-intercepts, one about there, a little bit bigger than 0, and another one over here. And I'm not going to put all the marks and everything on there, just to give you an idea of what that graph looks like, right? So once again, there's the actual graph on my calculator, which I tried to reproduce up on the board there as best I can. I think I did a pretty good job. All right, so there's my graph. So when I'm using this x-intercept method, again, I set everything equal to 0. I graph this side of the equation, obviously not the 0 side, the side that has all the stuff on there. And now I want to find those x-intercepts of this graph, and those x-intercepts are going to give me the solutions to this equation. Right? Because remember, this is almost like if we had an equation y equals x squared minus 4x plus 2, but I'm setting y equal to 0. Remember, when y equals 0, that's where you get x-intercepts on your graph. Right? Wherever that graph crosses the x-axis, the y-coordinate of those points is going to be 0, right? Because it's not up in the positive y values, it's not down in the negative y values. It's right there on the x-axis, which is y equals 0, right? So that's why I set everything equal to 0 before I graph. And now if I find my x-intercept, I have my solution. All right, so to find the x-intercepts on here, I go to the calculate menu. So if you see that trace button up there, I have to do second and then that trace button. All right, so I do second trace. That gets me to the calculate menu, and now I want to find number 2, which is the 0 of the function, right? A 0 is another word for the x-intercept, right? Or the value of the function that makes it equal 0, which is exactly what we're looking for here, right? So I choose 0 there, and then it asks me for a left bound, right? And you can see the cursor is like right there on the point that's on the y-axis, blinking, right? So it asks me for a left boundary, which is basically saying, well, what I need to do here is I need to put my cursor first a little bit left of my x-intercept, and then I need to put it a little bit right of the x-intercept, and my calculator is going to search between those 2 points and find where my equation equals 0. Right, so for my left boundary, right, that cursor is already a little bit left of that first x-intercept, so I just hit enter. Then it asks me for a right boundary, right, so I move the cursor to the right a little bit so that it's on the right side of that x-intercept. So you can see down there it's now on the right side. I hit enter again. Then it asks me for a guess. You can just hit enter for the guess. And you can see down there at the bottom, I don't know if you can see it too clearly, but it's telling you what the coordinates of that x-intercept are. And it is x equals 0.5857864 and y equals 0. Right? So it gives us the x and y coordinates at that point. Right? So this point right here is x equals 0.58578. 0.585, let's call it 8. right? If we round that to 4 decimal places, just so I don't want to write too many numbers there. Right, so that first x-intercept is 0.5858, more or less. Right, now, one of the disadvantages of the solving by graphing methods is that it does not give you the exact answer. Right, 0.5858 is not the exact answer to that equation. I rounded it off, right? I had to take that decimal and round it off, so it does not give me the exact solution. But it does give me a numerical approximation, which in a lot of cases that's good enough for solving the equations. Right, so that's my first x-intercept. That's one of my solutions to this equation. For the other solution, I have to do the same thing, but now for that other x-intercept. So once again, I do second trace to get back to that calculate menu. I do number 2 for 0, so I can just press the number 2 to bring up to 0. And now once again, it asks me for a left bound and a right bound. So I move the cursor over to the right, but I stop before I cross that other x-intercept, right? So I leave it so that it's a little bit to the left of that x-intercept. I hit enter. Now it asks me for a right bound, so I'm going to hit the right button and move it a little bit so it's on the right side of that x-intercept. Hit enter again, right? And once again, what I'm doing is I'm telling the calculator, search between this point here where I put the left bound and this point here. Search between those two to find the point where this graph hits y equals 0, right? And we have to do that for the calculator because the calculator is only able to find one x-intercept at a time. So that's why we have to say, well, just search between these 2 points and give me that x-intercept, and now do it again and search between these 2 points to give me that x-intercept, right? We can't just say find the x-intercepts and have it give us all of them all at once, right? It can only do one at a time, right? And then for the guess, once again, I just hit enter. And you can see at the bottom there, it's giving me an x coordinate and a y coordinate, right? My x is 3.4142, right? So the x coordinate of this intercept here is, I already forget what I said, 3.4142. Right, now once again, that's not the exact answer. It's 3.4142136. And that is also not the whole answer. I'm sure there's more decimals after that. That's just as many as my calculator displays when I do this. Right, so those are decimal approximations of the x-intercepts. They're not the exact answers, right? If we want to get exact answers, we would have to go back and solve this equation up here. And it looks like for this one, we would have to solve that one using the quadratic formula and go through all those steps. And it's probably going to be something that involves a square root, right? So, you know, if you didn't watch the video that I did about solving quadratic equations using that quadratic formula, you know, the numerical answer, like the answer to this is going to have some type of square root involved. But just looking at these decimal numbers here, I have no idea what that actual exact answer is going to look like unless I actually go through and algebraically solve the equation, right? So if you need exact answers, you want to solve it algebraically. If decimal approximations are good enough, you can just use this graphing method. All right, so that's how we solve that equation graphically. There's a couple more up here just real quick. They're related equations. So for the next one, I have x squared minus 4x, and then instead of plus 2, I have plus 4. So I just go back to my y equals screen, and I just change that plus 2 to a plus 4, hit enter, hit the graph button again, and now as it draws my graph, we can see it looks like that graph only has the one x-intercept, right? It looks like the vertex, or that low point on the graph, is sitting right on the x-axis. All right, so this graph looks like this. All right, so once again, if I want to find my intercepts, I'm just going to cut right to it so I don't waste too much of your time doing this. You don't need to sit there and watch me hit all those buttons on the calculator all over again. Right? I would do it the same way I did this. You know, second trace, the calculate menu, calculate the 0, the left bound, the right bound. This one is going to be at x equals 2. Right? So this one only has the one x-intercept. So this is going to be one of those ones where, since this comes out to a whole number, I could solve this equation by factoring. Right? This will actually factor into x minus 2 times x minus 2. Right? Those two factors are exactly the same, which means I really only have one solution. Right? I get two solutions from the factoring, but they're both the same solution, so there's really only one of them, which is that one x-intercept at x equals 2. Right? If I did this one by using the quadratic formula, it would be one of those ones with a quadratic formula where when I do all that stuff inside the square root, I would end up with a 0 inside the square root, which then forces me to only have one answer. Right? And again, I did a problem like that in one of the videos I did of solving quadratic equations. So if you're not sure what I'm talking about, you can go back and look at that and see what that looks like when you use algebraic methods to solve something like this and only get one single answer. All right, the next one up here, x squared minus 4x plus 6. that graph is going to look something like this. Right, just to prove it to you. I go back into my y equals, I change my +4 at the end of the equation to a +6, right? Everything else in there is the same. I hit enter, I hit my graph button again, and when it draws that graph, we see that that one actually doesn't cross the x-axis at all, right? So there's no point in going through and doing the second trace and trying to calculate the zeros because there are no zeros. That graph does not cross the x-axis. Therefore, this equation is going to have no solution. Right? There is no real number that if I plug it in here for x, it's going to make that equation equal 0. Right? So for this one, there's no way I would be able to factor this. And if I try to use the quadratic formula on this one, it would be one of those ones where when I do that stuff inside the square root, I end up with a negative number inside the square root. Right? When I end up with a square root of a negative, that's not a real number, right? That's an imaginary number or a complex number, and that translates into, when I draw the graph, it doesn't have any x-intercepts, which means there's no solution to this equation, right? So a few different things that can happen with these quadratic equations, right? We can get 2 solutions here, we can get 1 solution or no solutions, and this is what it looks like graphically. 2 solutions, that parabola crosses the x-axis 2 times, right? For the 1 solution, that parabola is just kind of sitting on top of the x-axis and the 1 point is touching it, or that parabola can be completely above or facing downward completely below the x-axis, never touching the x-axis, therefore there's no solution. All right, so that's, again, a couple examples using that x-intercept method. Everything on one side equal to 0, draw the graph, find the x-intercepts, those are your solutions to the equation. Not just for quadratic equations, but for whatever type of equation you're trying to solve, you can use this x-intercept method.